and welcome to this topic on Airbus. This is going to be a general information on the Airbus, in particular the A320, and also just some of the history of Airbus and some of the models that are outside of this Gen Fam, but just so that you're aware of those model names. This particular topic is going to be broken up into 9 different subtopics. Number 1 is going to be the history of Airbus and also familiarity with the different model names. Number 2, session 2 or topic 2 is going to be on electrical grounding. Number 3, ground service and drainage points. Number 4, jacking it up. We're talking about jacking up the aircraft. Number 5, towing and taxiing. Number 6 is leveling. Number 7 is zones and datum lines. Number 8, the different stations. And lastly, number 9 is equipment identification using the functional item numbers. Let's go ahead and start with topic 1. This topic is on history of Airbus company, the Airbus company and the models. They've gone through different changes, as you probably have known just from this industry, but also other industries, that when you have a company that grows and grows and grows, you're going to have reorganization, mergers and acquisitions, etc. So I mention this because with the Airbus that started back in the 70s, it's been called by different names along the way. Again, with intent to, keep up with the success of that business. And just to give you an idea with the Airbus today, as far as where is it located, as far as manufacturing, etc., they are in different places. One of them is in Hamburg, Germany. Their headquarters is actually in the Netherlands, in a place called Leiden. And they also have the kind of final assembly plants. One of them is in the United States, in particular in Alabama. So that's one of the manufacturing locations, is the state of Alabama in the United States. And so there's, again, they're obviously a huge company, airline or manufacturing company of aircraft. They also make other things as well, not just aircraft, but just related aerospace products. When it comes to the model names, all the model names begin with the letter A for Airbus, and then you have a designation of 3 numbers. So, for example, we're going to be talking, this pertains to the Gen Fam now, is the A320 Family. Or when they talk about A320 Family of models, which models are we talking about? Well, the A320 in particular is a model of Airbus aircraft that has become the template for a few other models. So we do have in the A320 family the A319, the A321, and the A318. Now, A320 is kind of your base design, etc., for creating the A321 and also the A319. Now, it goes in 2 different directions. So with the A320, what they did with creating the A321 is they added frames to the fuselage, so the overall length of the aircraft. In particular, they added actually 13 frames. So it's about translates to about 23 feet of length, so you have more, obviously you can carry more passengers, etc. And the other thing too, with some of the what they call the stretched A320, is the A321, is modifications to winglets, possibly a different engine, and I'll talk about also some of the engines that are installed in a variety of models of Airbus. So you have that improvement with the A321 as far as that goes. And on the other hand, we have the A319, which is actually shorter than the A320 by 7 frames. So it's shorter by about 12 feet, but it has its purpose for short-term flights. There's also the A318. That is going to be the smallest airplane of the kind of that group a little bit. So they're all narrow body. The changes that you might see with that is going to be, again, your overall length So on your x-axis, right, from fore and aft, and then also your wingspan can be different. So that's important to note, because if you're, well, for one, if you're not familiar with Airbus at all and never worked with Airbus aircraft, then, you know, it's just completely new. And, you know, but if you're used to, for example, working on A319s, and now you're towing the A321, well, you've got different measurements. If you're going to be towing or taxiing, or, you know, going to have to move the airplane, you've got to be, of course, you know, aware of those dimension differences. It's for obviously not damaging the aircraft. You also have some other models outside of the A320 family of aircraft models. You have A330, there's your A340, which is a 4-engine aircraft, your A350, and the largest one right now is the A380 of the group, so Airbus. And there's been some changes, again, like I said, with the engines being fitted. You have a variety of engines. You don't just have one, you know, brand of engine in the Airbus. You have the CFM 56. You may have the CFM LEAP, which is an improvement on the CFM 56, you know, -5A, -5B, if you're familiar with Boeing. I don't know, I'm switching here to Boeing a little bit, but Boeing uses the CFM 56, so they're outfitted with that. But so are some of the Airbuses. The CFM LEAP -1A, LEAP, by the way, in case you're interested, stands for Leading Edge Aviation Propulsion. Essentially, what they did is design it so that it had uses less fuel, so it has a more of efficiency, you know, internally. You have that, as well as some of the, you know, the winglets will be different, that kind of thing. But engines, as far as engines go, you can also have the Rolls-Royce engine. There's Pratt & Whitney as well, some of the Pratt & Whitney 1000 model series, and also the V2500. And you may have some variants with those type of engines as well. So just to kind of give you an idea that you just never know what you're going to get when if you're a contractor and you show up to an MRO and you get there, you know, you're going to get your orientation probably there for a week, but you know, it's specific to every MRO because of the customer base, right? So it depends on which customers they have and what the fleet is and what they're coming in for, as to you know, what you're going to actually find under the hood, so to speak. Okay, so that's what you have with that. Okay, so just remember your A318 is your smallest of the A320 group. Your A320 is kind of like your base. It's like your base template for creating a slightly shorter aircraft, which is the A319, or a stretched out A320 model, which is your A321. And as far as your engines and types of engines, those are a variety of them. All right, so just wanted to give you an idea with that. We're going to go into a little bit on dimensions. On dimensions, I don't want to get too detailed. You don't have to memorize any of that information, but I do want to just mention some facts about it. On dimensions, when it comes to the A320 the A319 and 20, so when we're comparing the shorter version, which is the A319, to the A320, they're almost identical, except for the overall length. So from, you know, front to back, your fore and aft, that's going to be a bit longer. Also, some of your wheel axis, for example, from your nose landing gear to your main, you're going to have axis distance differences there with those two planes. Your wingspans, okay, wingspans are going to be slightly different. Vertical stabilizer, you know, you may have some differences there as well. Okay, so, and obviously off the ground, so your height from ground, let's say, to, you know, the wing. So just to give you some idea with that, and of course you can see some diagrams about, you know, what those are, but again, it's the main thing that you want to take away is that you want to be mindful of those dimensions. If you're trying to get the aircraft out of the hangar, obviously you need to be careful that it's not going to the wings are not going to hit anything along the way as you do that. All right, so let's go ahead and go. That's session 1. I know it's quick, but there's not much to that. Let's go ahead and go to topic 2 or session 2. This is going to be on electrical grounding. The other thing, and I don't know, some of you may or may not be, maybe been an electrician in a previous life. I'm not trying to make you electricians by any stretch at all, but I just definitely wanted to mention to you that just with any system, whether it's on the ground or up in the air with an aircraft, is that when you have a lot of systems running together, you have equipment, and mostly in particular we're talking about metallic equipment, and you want to make sure that you have protection against static electricity. So electricity just kind of stays, that can actually just kind of linger on an aircraft. So you want to make sure it has a way to kind of go somewhere, and that's what you have with the electrical grounding here. Is the grounding that you have is being able to have the electricity be connect to the ground, and then you have a bonding situation which enables an electric potential to be the case across all the equipment. So it has to be, all the electric potential has to be about, basically the same for all those all that equipment. Okay, and then you have grounding points for the A320 and A320. That's going to be your nose landing gear, your main landing gear, so think landing gear in general, and then you have also your wing upper surface is another grounding point, and then also your engine air intakes. Those are also a place where you can just walk over, and then that's just follow procedure, but that's another area on the aircraft where you can ground the aircraft for safety against electric shock, okay, to personnel. Okay, so that's what you have with those, with the electrical grounding. Again, not much to it, just know that those are the points for doing that. And let's talk about this. Go ahead and move on to number 3. This is going to be on your ground service and also your drainage points. Drainage points and ground service, of course, you have to know where all the doors are located. If you already took the doors section or instruction, then you would have gotten some familiarity with where all those service doors are located. So I'm just going to give you some examples. These are not exhaustive, but at least it may jostle your memory with some of the things that you might have heard before. Your external power receptacle is one place. You also have your potable and your aft lavatory service doors, your forward lavatory service doors as well. And then you also have your high pressure air ground connector. Your hydraulic system ground service panels are part of that. Your refuel defuel coupling, and of course your refueling filling panels. They're going to be on the Airbus on both sides of the aircraft. So you got right hand side and left hand side for gravity filling panels. You also have your refuel defuel control panel. And then you also have your auxiliary power unit oil filling connector. So just giving you some examples of those ground service areas. And as far as your drainage, you have different points of draining water. That would be your water drains for your potable water, as well as your fuel water, basically just condensation that gets collected in the fuel. So you have a drain for that. And then you have your mast, your drain mast water area, and your drain mast fuel, drain mast water at 2 different locations. Okay, so that's pretty much what you have for that, and that's about it. Okay, and then we're going to go ahead and move on to the 4th section. This is going to be on jacking up the aircraft. So if why would you need to jack up the aircraft? Well, I mean, obviously, if you wanted to change a tire, right? Just like anything in life, if you, as far as changing a tire, you've got to lift up the aircraft. So that's what that'd be one reason we need to do that. So jacking up the aircraft is going to be, you're going to need to do some maintenance on it. Okay, you want to be cautious of a few things. For one, when you're jacking it up, you don't want to just. You've got to use 3 points at which you jack them, and you need to make sure they're situated exactly where those points need to be, not just anywhere underneath the aircraft. The points are going to be under the forward fuselage at frame 8, there's a permitted load for jacking, and that's approximately 15,000 pounds. The other 2 points are under the wings, and that's going to be at rib 9. I don't get hung up on the rib 9, rib 8, whatever, because again, I want to make sure, even though they're pretty much the same, except for I mentioned about dimensions, I still want you to just think about following AMM and not worry about anything else other than you need to make sure you have 3 points of jacking it up, and where those are located are going to be forward fuselage and also the underneath the wings. The other thing you want to be aware of is you don't want to lift the aircraft with the safety stay, okay? And you don't want to use the tail safety stay when the aircraft is on its wheels, okay? You want to take that away before you do also any testing on the landing gear, because you'll cause some problems with that, so be careful with that. Lifting of the aircraft, if you're going to do it for for wheel change, you want to make sure that you don't have any flight control movement, okay? Any flight controls moving, so during that time. So you want to make sure that you set on the 50 VU panel, you want to make sure that you release the push buttons with the push button switch. You want to make sure that you release the hydraulic leak measurement valves, and that's to be to the off. And that'll show up, when it turns to off, it'll actually illuminate, so you can see that. The other place too is on the 40 VU panel, you want to release that push button switch for the hydraulic blue electric pump push button switch. That'll be on off as well. Also, before you do any jacking of the aircraft, you want to put the parking brake switch to the off position, okay? And make sure that the aircraft is not tilted in any way. You want to actually make sure that's level before you start doing that kind of thing with the aircraft as far as lifting it. Okay. All right. So what else do we have with jacking it up? Well, what if you need to change the wheel? On wheel changes, you're gonna have the jacking for, let's say, obviously for the nose and the main wheel changes. Those are going to be located on the lower portion of the struts as far as the points at which you want to jack it up. Again, make sure that the aircraft is stable and it doesn't move during this time. Otherwise you'll have a potential problem, injury or damage to the airplane. Okay, so just be careful with that. Also, the other thing, don't try to do 2 things at once. If you're jacking up, concentrate on just that task only. Some people have tried to probably, I've got the plane here, might as well go ahead and fill it up with gasoline, fill it up with fuel. You don't want to be doing those 2 things. You want to make sure that you stay with the task of doing the wheel change, keeping that airplane level and steady and stable, and then finish out that task, get plane back to being jacked, okay, so it's no longer jacked up, and then do your refueling or your defueling procedures. All right. And diagrams can help you see where those points are located, etc. That's on lesson 5. Let's go ahead and jump to some questions. Just want to make sure I don't forget to give you some of these. Number 1, if you follow along in your handout, name one of the manufacturing locations for the Airbus aircraft. Okay, is it the state of Alabama in the United States or Nagasaki, Japan? Okay, the answer is the first one, right? Okay, number 2, which model of Airbus is the smallest of the A320 group? Is it A318 or A321? Okay, you're right, it's A318. I said that A318 is the smallest one. Number 3, the A319 is the largest of the A320 group. Is that true or false? Okay, that's false. Which engines are installed on the A320 models? Is it only the CFM56 LEAP, or is it a variety of engines, including the V2500, CFM56, or PW1000, Rolls-Royce? Okay, so the last answer, right? All right, on some of the questions for electrical grounding, when should you electrically ground the aircraft? Every 100 hours or when you do maintenance? Okay, anytime you're going to be near an airplane, you want to make sure that static electricity is not everything's grounded and you don't have that potential electrical energy kind of just not, kind of that's out there in limbo, because it will find a conductor somewhere. You don't want to suffer any electric shock. So the answer is when you do maintenance. Number 6, what is it called when you create the same electrical potential for all equipment? Is it bonding or grounding? Okay, you're right. Remember I said bonding. Grounding is grounding a piece of equipment. We're talking about like the aircraft to ground. Bonding is that you're bonding kind of the electric potential across a multitude of, a host of equipment, so that they all have the same electric potential, and there's not one above the other, and now you have a differential, and then you have a problem. Okay, number 7, what pieces of equipment could be at a risk of electric shock? I didn't mention equipment, but what equipment's on the aircraft. If they're not bonded, you definitely don't want to have static electricity near fuel tanks or hoses. So definitely that. Oxygen mask is not the answer. The answer is fuel tanks and hoses. All right, number 8, static electricity buildup on an aircraft can cause interference with what kind of important equipment? Okay, what do you think? Is it hydraulic system or radio and navigational equipment? Okay, you're right, radio. We know that type of static in the air interferes with the waves for communications, or this navigation, or radio for communications, or even for navigation as well. Number 9, if you wish to ground the aircraft, where are the points to do it? Okay, your 2 choices on the handout: landing gear, engine air intakes, and wing upper surface, or landing gear, engine air intakes, and wing lower surface. Okay, the answer is the first answer, right? Okay, an example of a ground servicing point. Okay, I'm on number 10. An example of a ground servicing point is the hydraulic system ground service panel. Is that true or false? Okay, that's true. And then I mentioned the external power receptacle. Is that a drainage point? No. I would hope you'd know what that was. All right, jacking it up. Question number 12, do not use this tail safety stay when the aircraft is on its wheels. Is that a true or false statement? Okay, the answer is true. Number 13, how many points must you have in order to lift the aircraft? Is it 3 or 5? Okay, that's 5. All right, that's enough. That's enough for now. It gives you an idea with some of those questions. All right, let's go ahead and go to our next session. This will be on towing and taxiing. Towing and taxiing, you've got, there's different procedures. You definitely don't want to have the engine cowls open, by the way, when you're towing or moving the aircraft at all, because you can cause damage, obviously, to the cowls and also the nacelle structure as a result of that. So on towing, the only time you're going to be essentially towing the aircraft is because you're doing maintenance. And also, just so you know, you can either keep the tires as they are, or you can actually deflate the tires when you're towing the aircraft. Okay. Also, as far as the towing equipment or tools that you're using, it's going to be a tow bar. There's different kinds of tow bars, but the tow bar that you want to use for the Airbus is one that has a damping system. You can use other ones, but it's highly recommended that you use a tow bar, which, by the way, I would check with the MRO where you're working at, because I'm not trying to say anything bad about MROs, but I will say that there have been cases where the MRO did not follow the recommendations of the manufacturer of that aircraft, and they did something else because it was less manpower or took less time, etc. And it ended up causing damage to, actually in this particular case, the engines, the engine cowls, and obviously that had to be replaced. So it cost them more money because they didn't follow a recommendation. So you may want to be aware of that when you're actually getting procedures to do something at the MRO. Is it something that they just have in place to cut corners, or is it something that came straight from the manufacturer, namely in this case Airbus? Okay, but the tow bar here, one that has a damping system. There are different maximum weights okay, with it, etc. So just make sure that the tow bar that you're using is rated properly for what you're doing. Okay, and then limit loads. You've got towing configurations. You've got safety pin locks, safety pins that lock the control lever on the interphone box, and that's what you want to have. Is have that safety pin locking the control lever when you have an aircraft in a towing configuration. And some of the things you want to also will see that you need to be aware of, and I'm talking about on displays, is some a message, for example, will be an NW for your nose wheel, NW, STRG for steering, DISC message that has no association, by the way, with another message that has a skid and your NW STRG switch. So just so you know, there's no connection between those two messages. Okay, beware of towing angles because they can't go past a certain angle. Okay, and those are usually shown on the actual fuselage, but definitely be at least aware of those little details. Okay, as far as taxiing, taxiing, there's a caution. You want to be careful with air blast from the engines, because that can be obviously a lot of power, a lot of force, even when you have lower thrust settings. I mean, the engines are huge, right? And you've been around them, so you know how big they are. 8 maintenance technicians have died from, being around engines that are running even just a little bit because of just that force, that suction power with those engines. So be careful. Also with the blast from the actual engines. And then be careful with the turn radiuses. This is all tied with the nose wheel steering. So, and if you're used to the Boeing's 737s are also obviously equipped with computers, etc. But the Airbus certainly has a lot of fly-by-wire mechanisms, and the nose wheel steering is one of those. Okay. All right, so just something to be aware of with the radius and taxiing of the aircraft. Now, what about leveling? Remember I said before you jack an aircraft up, you want to make sure that it's level. So what are the different ways you can level? Well, there's one easy way, and that would be with using the ADRU. Okay, your ADRU, and just looking also at the MICDU. But you have to do an alignment procedure first before leveling using the ADRU. The other thing too, with some aircraft, there may be an attitude monitor. If it is, it's actually located in the refuel defuel panel door on the right hand side of the aircraft. Otherwise, you're going to be doing the quick leveling procedure using the ADRU. And on the MICDU, you're going to push the mode key for MICDU menu, just to bring that menu up, right? And then you're going to push the LSK adjacent to the AIDS. Okay, AIDS is your integrated data system, or excuse me, aircraft integrated data system. And then you're also going to push the LSK adjacent to the call-up parameter. And then you're going to push the LSK that's adjacent to the param alpha call-up. Okay, and then you're going to enter the correct alpha call-up code in the scratch pad, and then push that LSK that's respective to that in order to take over the parameter alpha call-up. So two examples of an alpha call-up code, and this is going to be for pitch and roll. So the purpose of the codes are for pitch. Okay, your pitch angle to do a check on longitudinal, right? And then your roll from side to side, your lateral or transverse alignment. So again, this is for getting that. You got to do that IR alignment first before leveling. And what you're going to do before lifting and leveling the aircraft, you want to read the pitch and the roll angles at the bottom of the display, okay, or that scratch pad section. Because you have a positive degree value angle of roll means when you have that, then the right wing is down, okay, and a negative degree value means that the left wing is down. So those are important, and of course the vice versa. The positive degree value of pitch means the nose of the aircraft is up, and then a negative degree value of pitch means that the nose of the aircraft is down. Okay, it's just like an X and Y axis that you have there. Okay, so that's what you have with the leveling, using the ADARU and also using the MICDO menu to make your selections on. Okay, so that is number 6, session 6. Let's go ahead and move on to session 7. This is going to be on some zones and your datum lines. It's pretty simple. What you have here, it's going to be on your zones are going to be to identify different areas. You have your major zones and then you have subzones. And your major zones are going to be, for example, your left wing, right wing. Well, those are pretty major. And then, of course, your landing gear in itself, all that landing gear assembly and components, that's all one zone. Your doors are another. Your nacelles are also another. And then your stabilizers, okay, your horizontal and vertical stabs. And then also your upper and lower half of the fuselage to the aft pressure bulkhead. Those are broken up into 2 separate major zones. And the way these are coded is with the letter Z, and then you have a 3-digit number that are going to be in hundreds. So for example, the right wing, if you want to say, okay, let's identify the right wing, that would be 600. Okay, if you wanted to identify the slats on that right wing, then you would have a 10-digit designation. So instead of 600, it would be 600, let's say 10, or it could be 610, 620, depending on what the component is and on. So that's how they're broken up, is your major zones and then your major subzones, in the example I just gave. Your data lines are pretty easy. Like I said about the X, Y, Z, we're talking about your X axis. If you took flight controls already, we explained, and you know probably already, but your longitudinal goes from forward to aft of the aircraft. That is your X line. And then you have your Y, which goes from left to right. Okay, so that's your lateral distance. And then your Z, of course, is your vertical, as if a stick was going right through, the center of the aircraft upward to the sky, downward. Well, it's all relative, right? But that's what I meant. So you get an X, Y, and Z, and those are your datum lines that are used as points of reference for measuring. All right. Okay, so those are what you have with the zones and datum lines. Now we're going to get into the stations. Your stations can be, I'll categorize it like this. You've got fuselage, right? I mean, if you look at the aircraft, you got a fuselage. You have a fuselage, and that's one station. The other station is going to be you have pylon and your nacelle stations, and of course then you have your wings, right? Okay, so let's start with fuselage. Your fuselage obviously is measured on the X datum line, okay, from forward to aft, front to back, and those are broken up into frames. So you have different frames, and of course, remember I said it depends on which model as to how many frames it's divided up by. Your A320 is your base model, and then you'll have some, about 7 frames less on the 319 from the A320, and then you have 13 frames more on the A321. Okay, so you have that, but just know that on the stations for the fuselage, they're broken up into frames. Your pylon and your nacelle stations, those are both also measured along the datum line. That's your X line. Okay, and then your stabilizer and your wing stations, those are at 90 degrees to the aircraft center line. So those are the positions of the stations for horizontal and your vertical stab. And then your wing has rib stations. Okay, so those stations are parallel to the X axis. Okay, and those are measurements. All those measurements are at 90 degrees to rib 1. Okay, and you have those ribs as designations there. Okay, so kind of the diagrams just give you a picture, and we'll have some pictures to help you with that. Okay, but again, you don't have to memorize anything. Just, I mean, for the test, you need to know something. But aside from that, just get an idea that you have your forward and aft, you have your longitudinal with the fuselage, and it's broken up into frames. Your wing stations are broken up, are based at measured at a 90 degrees to 90 degrees, okay, to your X. Okay, so that's what we have with topic 8 or session 8. That's on stations. And now let's go ahead into our last session. This is going to be session 9 on the equipment, because equipment is uniquely identified, and they have come up with a code in order to keep that unique identification. They are called functional item numbers, and depending on where the equipment's located, you're going to have a certain letter that designates that. So, for example, there's a list of these, and by the way, you can find all these codes in the wiring manuals. So, it's your MRO, you just flip that, or on the computer or whatever, you can see those. But as an example, the letter C designates flight control systems. So if there's equipment pertaining or part of the flight control systems, then there's going to be the letter C in that particular function item number. Okay, and if for example there's several components that are the same component, then the last number will be this in sequence, like number 1, number 2, 3, 4, 5. Okay, so an example would be like 2CA1. Okay, that's an FIN. That's an example of one. Mechanical stuff. If you have mechanical equipment, there's always going to be a designation of the letter M as an ending. So there's numbers and letters that make up part of the functional ID or item number, and they're identifying the system as well as the circuit, and of course the unique identifier for the actual equipment within the system and the circuit. Okay, so that's a general orientation of the Airbus and a little bit of history of it, and also the different models, and in comparison with those different models, as well as the engines that are outfitted with those models. And of course the dimensions are going to be different, so be mindful of that if you're towing or getting if you're towing the aircraft out of the hangar, and you want to make sure you have enough clearance. Do have a walker, of course, and make sure you're not doing things by yourself or just trying to cut corners. Oh, nobody's here. Be careful, because now somebody's plane, obviously. Okay, your dimensions, and then also, of course, major zones of the aircraft. So identifying an aircraft in general. You've got your fuselage, your wings, okay, and then of course you have subzones, those sub-major zones, and you have also jacking up the aircraft and the cautions. Beware, making sure that the aircraft is actually level and that it's aligned before doing any wheel changes, okay, which obviously you have to jack up the aircraft to do that. And then your ground servicing, all your service doors, where those are located, and of course your drainage points. And you want to also, of course, if you're doing any maintenance on the aircraft at all, to protect you from electrical shock, you do want to make sure that that aircraft is properly bonded and grounded. All right, that concludes our aircraft information, and just kind of general information on the aircraft. And obviously, if you have any questions, please feel free to email us. We are here to answer any questions and be happy to do so. That we look forward to. We thank you for participation in this particular topic, and we look forward to having you in the other